Hello, this is Jim Sutton of Stone Tablet Innovations. Today we're going to do video blog number 6, which is running the Blink program on the Espressif ESP32 system on chip. This is the first time we actually make something happen, which will be a light blinking on and off. So the goal of this video is simple. We're going to show you how to run a Blink program on a Windows 10 computer. The prerequisite is installation of the development framework, which we showed in pretty much detail in video blog 4. You may also want to refer to video blog 5, which is running the simplest program at all, the famous Hello World. Throughout this, I'm going to refer to steps in the Espressif tutorials, and I'll use their numbering so you can refer, so it'll make sense if you're looking at any Espressif information. You can maybe go back and forth a little bit. The target hardware is the ESP32 Dev Kit C 32D, which was also described earlier. So there are some common steps in running any program, and I'm just putting them out here so that it'll make sense. These are the steps Espressif likes to separate things into in their documentation. So you have to start a project and build a directory in a very specific structure. For right now, we're copying, and so we automatically get the directory in the right structure. Then you connect to your device, which is done by plugging in the USB cable. Then you do some configuration. Then you build the project, and then you have the binary code that you can flash onto the device. And then you can hit a monitor. Now we're going to make a new project for our blinker example. So I'm going to, again, it's easier to make new directories with the Windows commands versus typing in the names. You just click on it. So in ESP, which is where the framework downloaded all the examples, we're in the subdirectory examples. And Get Started has the two most basic ones, which is Blink and Hello World. We already did Hello World in the last blog. So I'm going to copy this, and we're going to go back to ESP32, and we're going to make this one as a nice clean project in STI projects. And we'll paste it. Now, just to keep order and disorder, I'm going to rename this to 02_blink. And again, we don't want to put blanks inside path names. It causes all sorts of problems with the automated tools provided by Espressif. So just taking a quick scan inside of here, we have the main. Inside main is the core blink .c program. And if I go back, we have a bunch of CMAKE lists all through here, which give instructions to the program CMAKE when it comes time to assemble. Now, let's spend a second on the hardware, which I've discussed in earlier blogs. In this one, we have to add in an LED to turn on and a resistor. So I've shown it schematically here. We're going to hook it up to pin labeled 23. That's IO number 23. And so we have a 220 ohm resistor and a run-of-the-mill LED going back to ground. And I have a little picture of what it looks like on my breadboard. I included a little picture here so that you get the orientation from anode and cathode right on the LED hardware. So the one other piece about the hardware is you need to plug it in. This is a micro USB connector on this side. Plug it into a USB port on your Windows 10 computer, and then you're ready to go to the next step. After you use your ESP IDF command prompt to set the paths, and then you can navigate to the Blink directory. So we'll go first to the STI projects directory where I'm putting all of them in. Then we'll go to the 02 underscore blink where we've put in made our new project. So now that we're in the right place, we want to tell CMAKE what kind of target hardware we want it to produce the right code for. So we do that with the idf.py set-target ESP32. So it has to do a little bit of work to get there. You only need to do this one time to set the target. After that, we don't have it. It'll keep using the same information. So all the configuring, generating, and building has been done. So now we want to run this idf.py menu config. This is a program that Espressif has made to make it a little bit easier to enter in variables. So instead of going into the code and changing the port number for the blinker, they've made a little place to store the configuration information. And so generally the way they've got it structured is whenever you're running an example and it needs a configuration detail like the IO port that you hooked up the blinker to, they let you enter it in here rather than editing the code. So the blink GPIO number is what we want to change, and we want to put in 23, which I think I showed you on the other hardware page. So we just hit enter and escape to get back to the main menu, and we're going to do save, and it's going to save that information. Okay, so it did it, and we're ready now to quit because that's the only configuration information we need to do. So again, you quit with the escape key. After you finish the configuration, you're ready now for what Espressif calls steps 8 and 9, which is build and flash. First, make sure you're in the right directory if you're not continuing on from the previous slide. The command is simple, idf.python build. And it does a lot of work for you. I've separated this into two pieces, build and flash, because conceptually they're different for me. But as a practical matter, if you can actually skip this command called build, because as soon as you get to the next command called flash, it will check to see if the build is current. And if it's not, it'll automatically run build for you. But in this case, we're going to just do it in two separate pieces. So I'm going to pause for a minute. We're up to object 270, and it's pretty clear. It'll just take a couple of seconds to get to 940. We're coming back after the brief pause. Again, the first time you build it, it takes the longest. Ninja, the next time, will make it go quite a bit faster. So it's now completed successfully, and we're ready to run the flash command. And I have a few more details on running this flash command in the last video, including how to connect the Espressif ESP32 development board to the computer and find out which port it's connected to. So if you know, that's in video blog 5. So you might need, if you're confused about what port you're connected to, you refer to that one. So as I just said, we got to do tell it which port, which is COM3 in this case, and we need to tell it the baud rate, which is 115/200. Then we need to give it a command called flash. Now, as soon as I hit the enter key, it will start the process of communicating to the ESP32 development board. It needs to be in the flash mode, and I'm going to force it to do that by holding down the boot button, and I'll tell you when I'm pushing a boot, just so it's clear. Okay, it says connecting, so it's waiting for it to get into the flash mode. So I'm holding down the boot, and so it recognized it, and it's uploading the stubs and writing the program. We're now up to 100% complete, and it's done a hard reset as well. Well, it says it did it, but I know I actually did it by pushing the pin as well. And now the program is running, and on next screen I'll show you what it looks like. Here we are, it's blinking away at 1 blink per second. You can see there a little bit my resistor, and but it's kind of small. It's actually 220 ohms. With the blinker program running, now we can also look at it from the monitor and see what they programmed in. And you can see it dumps some information about the compilation and partitions, and then it just sends out a message on the monitor turning off the LED, turning on the LED, and so forth. So we can stop that by that sequence of keys Control plus and then that close brackets, and that stops the monitor program. So now we've got everything working, so why not try and break it by editing and rebuilding the Blink program. So there's a series of steps here that will go pretty quickly and very quickly once you get really used to it. So let's get ready to edit the Blink program. Now that we have the Blink program working, let's just show how we could change the blink interval a little bit with a simple edit. So we're going to go into the ESP directory we made in an earlier tutorial, and we're going to look for the STI projects and O2 blink. I'm keeping these in order. And the main will have the blink.c. So when I double click on this, it'll open up my Atom text editor. Pretty much any text editor will do what we need to do here. And it's always asking questions. So here is the blink.c program, and we'll just go through a couple of items in it. We have some includes, the standard IO library, the free RTOS library, and this is where it pulls in SDK configuration library, which is where we set the port number, if you remember. And here it's defining the Blink GPIO as from that configuration file up here. So then we get into the main program, and this is where you can look at this a little bit more detail. It sets the pad as a GPIO, and while true, we're going to turning off the LED, and so we set the level to 0, and then here is where we wait for it to go back on. So let's change the interval from 1 second to 5 seconds. So we're going to now turn it off for 5 seconds, then on for 5 seconds, and continue indefinitely. So we're going to we'll save this, and we're all done with that. So I'm going to close it, and I'm going to close this. So now we're going to go back to our this little batch file here, and I'll blow this up a little bit. And let's see if now we'll change directory STI projects and change directory or current directory, some people do, O2 underscore blink. And now we can do idf.python dash port is COM3 dash baud is 115.200, and we're going to do flash, and we're going to add monitor in. So I'm going to show you two things this time, that how it's going to do a build on this, because we changed one of the files. now it's ready to connect. So I press the reset button and cause the bootloader to start working. And now it's running the program, and as you can see, it turned the monitor on as well. And now you can see that instead of going on and off every 1 second, we've changed the interval to have it go on for 5 seconds and then off for 5 seconds. And that's what I wanted to show. So I'm going to turn this off now. So wrapping up, we were able to build, flash, and monitor a simple Blink program. And then we showed how to change the Blink program to a different Blink frequency, rebuild it, and flash it, and make that work. So thanks once again. Subscribe to the channel if you're interested in ESP32. We're going to continue building up to more and more complicated projects. But thank you again.